Welcome back to the deep dive. Today we're getting into the real operational guts of the internet. We're not talking about the flashy high-speed stuff. We're talking about the critical hardware system admins use when everything else is on fire.
Right, when the main network is down, crashing, totally unresponsive.
Exactly. So our mission is to unpack this idea of a hidden backdoor. It's a lifeline. We're using the NTI SERIMUX-S-32 console switch as our guide, and this thing it handles up to 32 critical devices and costs, what is it, just about $8,865.
Yeah, which is fascinating when you think about what it does. We're really talking about out-of-band access, or OB.
Okay, OB.
It's a access path that's, completely separate from your normal network traffic. If the main highway for users is blocked, this is the private emergency road.
So you still get in to fix the problem.
That's how you maintain uptime. You can log into routers, servers, whatever, without being locked out. It's like having a secret key.
And that separation is everything. This switch, it controls those 32 devices over TCP/IP or sometimes even a dial-up modem in a real emergency.
The modem, yeah. Talk about a last resort.
But the real genius here is the efficiency. It completely gets rid of the old way of doing things where you had to have a separate computer, an ASCII terminal.
A physical keyboard and monitor for every single server.
Right. Next to every single piece of gear. Imagine the space.
Oh, the space and the cost. You're taking 32 bulky emergency machines and you're replacing them with just one sleek little box in a rack.
And because this is your access point during a crisis, the security has to be, well, perfect.
It has to be unhackable. So it doesn't run on some general purpose system. It's a hardened Linux system.
Hardened.
And access is locked down tight with things like secure shell SSH v2 and HTTPS.
Okay, so access is secure, but what about actually connecting all those devices?
That's the simple part. It just uses standard, cheap CT5 cable, the kind you have lying around everywhere, and it can run for, I think, up to 1,000 feet.
1,000 feet. And here's a detail I love. The data rate is actually slow. It's like 115 kilobits per second. But that's the point, isn't it?
That's the whole point. You're not streaming movies. You're just sending simple text commands. In a crisis, reliability is so much more important than speed.
Reliability trumps speed every time.
Exactly. And that whole idea of resilience, it's baked into the hardware itself. The SERIMUX-S-32 is built to survive failures.
So that goes down.
It's got 2 Ethernet ports, redundant connectivity. If the power goes out, it has an option for 2 separate power supplies.
So redundancy on top of redundancy.
It has to. I mean, if the device that's supposed to manage your crisis fails, you're done. You have 0 chance of recovery.
And here's where it gets even more interesting to me. It's not just monitoring the network, it's monitoring the physical realm it's in.
The environment, yeah.
It can connect to 2 sensors, one for temperature and humidity, and another one specifically for detecting water.
It's the canary in the coal mine for the data center.
Totally. It's the eyes and ears inside the server room.
And this is all about proactive maintenance. If those sensors detect something's wrong, say it gets too hot or, God forbid, there's a leak, the system immediately starts sending out alerts. You'll see it on its own web page on little LED lights, but more importantly, it sends emails.
To a lot of people, right?
It can send alerts to up to 17 different email addresses. I mean, think about that. Someone is definitely getting woken up at 3 a.m. if there's a flood. There's no excuse.
And all that activity, every alert, every login, every command, it's all logged. The box itself is this rugged steel case, but inside, that logging is maybe its most important feature.
Absolutely. The event logs are all date and time-stamped, and they're stored in its own internal memory.
Which is critical because the main network storage might be completely fried during whatever outage is happening.
You've got an immutable record of what went wrong and when.
Yeah.
So at the end of the day, what is this thing? It's not for daily use. It's a piece of hardware built entirely for diagnostics, for crisis management, and for minimizing downtime. It's the silent hero.
So here's the final thought. If this one single device is the dedicated, secure lifeline for 32 other pieces of crucial equipment, what does that tell you about the incredible hidden complexity required just to maintain something we think of as simple, like uptime across the internet? It's a whole system just for managing failure. Think about that next time you load a web page and it just works.